Welcome to VW 1.3. Today we're going to be reviewing radicals. So first in our note, just write down these two expressions here. There are two situations that happen in a problem like this. You have a to the n power to the nth root. This will equal a if n is greater than or equal to 3 and n is odd. So for example, if you have like 2 to the third root, or like a perfect cube, you just get the number right back. So an example of this would be something like a 2 to the third root. We can see that that's simply 2. Or you could just think about it, that 2 times itself 3 times would be 8, right? That's how we typically approach radicals. And then for letter B, notice how it's quite similar. Some of you might just know the answer, but if you wanted to think of it algebraically, we can write it like -4 to the third power cube root. That would be -4. And again, a few people just think of it that way. Now, the reason we have to go over this is because it's actually quite different if n is even. So, all right, n is greater than or equal to 2, and n is even. A lot of people want to write a. That's actually not true. It's the absolute value of a. Now, you're probably wondering, like, why does that even matter, or why is that true? Well, look right here. You have the 6th root of -2 to the 6. If you simply wrote -2, that would be wrong, and I'll show you why. Let's actually work that out. -2 to the 6th power, that would be 64. And the 6th root of 64, that would be 2, because 2 to the 6th power is 64. So notice how the answer is +2. That negative goes away because of this even power. So algebraically, that's what this definition up here is showing, is that what actually happens is it becomes the absolute value of -2, which is then 2. Now the reason that's an important note is because of things like this. So make sure you guys put a box in your notes here. The root of x squared, a lot of people want to write x. To be precise, it's actually the absolute value of x. So that's going to be the pure algebraic definition of what it means to square root an x squared. And we have to apply that here. So let's look at a. I know you guys probably learned a lot of ways of doing this. I'll just show you what I do. I make the first radical here my perfect numbers. So in this case, perfect squares. So I'm going to put 16 and x squared right there. This is my leftover radical. That would be 2. So this becomes 4 times the absolute value of x times the root of 2. Or some people just put it together, absolute value of 4x root 2. And again, we need the absolute value because in the event x was negative, we don't want to have a negative in the final answer. So that's why you do need the absolute value. Now, if it's cubed, of course, we don't worry about it. So that's why in this one, see how there's no absolute value? If it's an odd root, we just don't even worry about it because that issue won't even happen. So I'll just separate it. I'm going to write -8x cubed here because that'd be my perfect cubes. And my leftover would then be the cube root of 2x. So we simplify this. The cube root of -8x to the third would be -2x. And our leftover is the cube root of 2x. And I know we're comfortable with square root, so that's why you don't put a number here because it's assumed. Don't forget to put this 3 here, otherwise you would get marked wrong because it is a cube root. And lastly, we have this one. We have to the 4th root here, so let's break it up again to our perfect, to the 4th number, so that would be 16x to the 4th over 81. Our leftover is x. We take the 4th root of that. That would be 2 times the absolute value of x over 3. And we're left with the cube root, or sorry, the 4th root of x. We can leave it like that. Or some people write the absolute value of 2x over 3 times the 4th root of x. And again, we're only doing that to account for the possibility that x could be negative. So you just gotta be careful with that with even roots. So notice how it's an even root. You always gotta be careful when that happens. Okay, there's our first two examples, done. Let's go to our last two concepts here. Now we're going to combine like radicals. So to combine like radicals, it's just the same thing we just did. We're just going to do it multiple times. So in this one, I'm going to separate it. 8x cubed, our leftover is x. On this one, I'm just going to pull out the -1 here. And then our leftover here is x. And for this, make sure you leave the 4 alone. Don't put that anywhere, just leave it on the side. 27 is a perfect cube already, so I'll leave that alone. And then there's our x. Now we're going to reduce everything. That's 2x. That's cube root of x. That's -1, cube root of x. This would be a 3, so 4 times 3 is 12, cube root of x. Let's simplify this to 2x plus 11, cube root x. So I forgot my cube root x over there. Let me move that over. And some people leave it like this, and I would accept this answer, but most people are going to want to factor because you see the common factor there. So I'm going to factor out cube root x, and what's left is 2x plus 11. So that's going to be like the most simplified answer. But again, if you left it as this one, that would be okay with me. Okay, last concept, rationalizing the denominator. So again, this should be familiar from Algebra 1. We just don't want a radical on your denominator, so let's multiply by radical 3 here to get rid of it. And our answer is root 3 over 3. Not too bad. Now, a common misconception is people multiply by the actual denominator. So I've seen some people do this. They multiply by 4 root 2 or 4 root 2. And you could do that, and that would get the answer, but it is excessive. There's extra work here. The only issue is the radical. So to make it easier on yourself, just multiply by the root 2 over root 2. And now we get 5 root 2 on the top, and the bottom becomes 4 times 2, which is 8. So notice how it's much easier. And the last example right here, notice how we have a binomial term down there, or there's two terms. So we're going to use what's called a conjugate. So hopefully you remember this from Algebra 1. A conjugate is this idea that if you have a plus b, that becomes a minus b. So for this problem, I'm going to rewrite it. We have root 2 over root 3 minus 3 root 2. I'm going to use the conjugate of the denominator. So multiply by root 3 plus 3 root 2. Now what's really cool about this is the conjugate creates a difference of 2 squares here. So that's why it's really useful. So when we multiply this together, the top, let's just distribute. That's going to be root 6 plus 6. But because it's a difference of 2 squares, that means the middle terms cancel and all the radicals are going to go away. We're left with 3 minus 18. So our answer, we can leave it as root 6 plus 6 over negative 15. And we can leave it like that. That would be fine. Okay, now work on the rest of the problems and bring your questions to class.